Okay, we're looking at the second year Stats and Mechanics textbook, and we're looking at exercise 6C, question 10. So we're on projectiles, so let's see what's going on here. Okay, so a ball is thrown from a point O on a horizontal ground. So there's my horizontal ground, with speed, capital U, and angle of elevation of theta. Okay, so we'll move up a bit so you can see it. Okay, so what is going to happen? Well, it's going to carry on in that direction. Gravity is going to bring it down, and it strikes a vertical wall 20 meters. Oh, sorry, still can't see that. So 20 meters from point O. Yep, so sorry, just checking I've got that in the right place. So that's 20 meters, and at a point which is 3 meters above the ground, find the value of U. Okay, and this is worth 6 marks, so I'm going to make us work for it. And the one bit of information I haven't written down yet is that tan theta is 3/4. Okay, so I could do inverse tan of 3/4 and get theta, and then do sine theta and cos theta that way. But there is a neater way of doing it, and that is to say, well, look, if tan theta is 3/4, and I know that tan is opposite over adjacent, if I then use Pythagoras, because obviously that's a right angle triangle, so if I use Pythagoras on that, I get a hypotenuse of 5. So then I can just get the exact values of sine theta and cos theta from SOHCAHTOA. So let's just get this out of the way. Right. Okay, so sine theta is opposite over hypotenuse, so 3/5, and cos theta is 4/5. Okay, so you don't actually need to find out what angle theta is to get the values that we're going to need for the rest of the question. Okay, so I'm going to need to think about the vertical and the horizontal components of this, or motion of this. So let's go horizontally first, because that's usually easier. Okay, so horizontally, the initial velocity is going to be capital U, and I want that component of it. So that's adjacent to angle theta, so it's going to be, colour change, capital U cos theta. I know that it gets 20 meters, and I know that because we don't have to worry about air resistance, that the horizontal acceleration is 0. So I'm going to call time t. Okay, so because that's always what I want for this type of question. If I'm looking at the horizontal and the vertical motion, it's the time that connects the two. So whenever it hits the wall at this point, obviously the time in the vertical direction is the same as the time in the horizontal direction. So because there is no acceleration, I can just use that displacement is velocity, because it's a constant velocity, times time. So 20 is capital U cos theta times t, and I know what cos theta is, so I can substitute that in at any point. Right, so then if I think vertically, so vertically, oh, and I should have said I'm taking right as positive there, and I'm going to take up as positive when I'm thinking vertically. So the vertical initial velocity is that part of it. Oh, didn't want to do that. Right, it is that part of it. So that's opposite theta, so that's going to be capital U sine theta. Acceleration is due to gravity, and I'm taking up as positive, so obviously gravity is working down, so that's going to be minus g. Its displacement in the horizontal direction is 3, and I'm calling t. So for this one, I am going to use S equals ut plus a half at squared. So 3 is capital U sine theta t, plus a half a, well, that's as A is minus G. I'm just going to say that's minus a half G T. Okay, I haven't actually read what I'm after yet. Right, I'm after the value of U. Okay, so so I've got these two equations that involve T and capital U. I do know what sine theta and cos theta are, so let's substitute those in just to tidy them up a little bit. So cos theta was 4/5, so 20 is 4/5 capital U T, and sine theta was 3/5, so this can become 3 equals 3/5 capital U T minus half G. Oh, sorry, crikey, sorry, I forgot my squared. So T squared, right. Okay, so I want U. So I've got two simultaneous equations, and I've got two unknowns, capital U and T. So I am going to be able to solve this. Remember, G isn't an unknown, G is 9.8. As it's U I want to find, it's T I want to eliminate. So the sensible thing is going to be to make T the subject of that one. So if I multiply up by the 5 and divide by 4, I get 25. And then if I divide by U, okay, so that's what T would be. And then if I substitute that, sorry, it's this one I'm looking at, into this one, I will end up with an equation in capital U that hopefully I'll be able to solve. So 3 is 3/5 times U times T, which I'm substituting for 25 over U. So that's a good start, so those U's will cancel, so that's handy. Minus G over 2, and then for T, I'm substituting in 25 over U, and that's all squared. Okay, so it looks a bit of a mess now, but I think it's going to be all right. So 3 equals, well, what have we said? We have said that they are going to cancel, and then also the 25 over 5 will cancel to 5, so that will just become 15. So I haven't done anything daft. And then let's square out those brackets. So okay, so 25 squared. So I've got minus 625G. So I'm looking at this bit now. So 625G when I scale the 25 over 2U squared. Do I want it in terms of G? No, just as the value of U. So you can leave G there, or you can substitute in for 9.8, whichever you prefer. Okay, so just want to try and solve this now. So 625G over 2U squared. So I'm adding that over to the left, and then I'm going to minus the 3 from the 12. So 625G, if I multiply up by the 2U squared, so U squared is 625, so I'm going to put in 9.8 for G. So 625 times 9.8 divided by 24 is giving me U squared of 6125 over 24. So yeah, I think if I'm square rooting, there's probably not a lot of point of leaving it in terms of G. So that is giving me 15.975. So I would give that as 16.0 meters per second. I'm going to double check that before we carry on. Yeah, so I've gone 16 to two significant figures. Ooh, how do I get that back? Right. Okay. So that's my final answer to 2 or 3 significant figures. So that was the bulk of that question, because that was worth 6 marks. What do they want for part B? So the time from the instant the ball is thrown to the instant that it strikes the wall. Okay, well, I think that's going to be fine, because I've got 2 equations in terms of U and T. So I think if we're sensible, we're going to use that one, because it's a lot easier. So I'm going to try and remember what that says. So 20 equals 4/5 UT. So 20 equals 4/5 UT. So 20 is 4/5 times 16 times T. So T is going to be, so 20 times 5 divided by 4 divided by 16. I am getting, so in exact form, 25 over 16, but I can't leave it in exact form because that 16 wasn't exact. So it wouldn't make any sense to try and pretend I had it in exact form. So 156. And I did use G. Oh, so in fact, yeah, so going back to this answer, it doesn't actually change the value, but I should, as I think they had in the book, have given that to two significant figures because I was using G to two significant figures. So same here. It doesn't make sense for me to try and give it to three significant figures, so that is going to be 1.6 seconds. And I think we saw that as the answer, but let's just double check. Yep, we're good.